It's like Blair Witch. Ooh. Right, morning everyone. Welcome back. So today is both exciting and a bit daunting because these bad boys have turned up. This is our 12 volt batteries, but we're going to be powering most of our stuff off. Now I'm going to do a very right back to basic explanation of how our electrical setup is going to work, because in our first van we didn't really bother, and in this van we want to have quite a decent setup, but I didn't have a clue how it all worked, what I needed, what everything run off, how to power everything, charge everything. So, and to be honest, it got my head spinning for quite a while. So to some of you this might seem blindingly obvious, but to people like me who just did not understand it, hopefully this might be a little bit helpful. So there's two types of power that you can run things from. I'm probably going to use all the wrong words, all the wrong terminology, but it might be the same terminology that most people make sense of. So two types of power, so there's AC and then there's DC, and to put that simply, AC, you've got your 3-pin plug, it's what you plug in your house and runs off of 240 volts of power. DC is direct current, and that's your 12 volt stuff that runs off the battery. So what we're going to do is we're going to put nearly everything in this van will be 12 volt DC. So all of our lights, all of our charging for our phones, the fridge will be a 12 volt compressor fridge, the water pump will be 12 volt. I've sourced 12 volt chargers for nearly everything we're going to be bringing with us. So nearly absolutely everything will run off of 12 volt except for the odd item. So yeah, so that's your 12 volt. And then where I found it got confusing is I was like, well, when we plug in on a site, all my lights are 12 volt, so what are they gonna run off of? Will I need a separate string of lights for mains power, or will I need to switch over, or what? But turns out it's quite simple. So pretty much everything will run off of these batteries at 12 volt DC. And then the simple thing is when we're at a site, we will plug the van in, there will be a charger that will charge these batteries, so power will come in, charge these batteries, and then it will go off as 12 volt power, and then all our stuff still just runs off these batteries. So it's not more so what you're running it off, it's where you're getting your power from. So this is our mains coming in. So I have put 240 volt in the van. By the way, 240 volt, 230 volt, mains power, shore power, that all means the same thing. There's just lots of different ways that people describe it. I think shore power is from when it was like boats and stuff. So yeah, our shore power will come in, and I've put in this one plug here. So from there, I can plug in a mains battery charger that will charge these batteries. And then I can still flick a light switch over there, and our 12 volt lights will come on because they'll still be running off these batteries. It's just these batteries will be constantly being topped up by the mains charger. I'm also going to put in one more mains socket that is completely separate from the batteries in the kitchen somewhere. And that is literally for if we're on a site in the winter in the UK and we want to run an electric heater, then we've got the option. Or if we're not planning on moving for a long time and we want to charge up specific items that we can't do through 12 volt, it's there if we need it basically. I think while I'm running cables I might as well put it in. So yeah, so that will be our power coming in, which will charge the batteries. However, we're not going to use that very often, so we need to find alternative ways of getting power into these batteries that can be stored, that we can then use to run our 12 volt stuff. So we're going to have solar on the roof, and we're going to have what most people call a split charge, but ours will be a battery to battery charger because we've got a smart alternator, which means we can't have a VSR. So plus I think battery to battery chargers are a bit better anyway. So I haven't got, the solar won't be going on till the spring, and the split charge, or the battery to battery charger, sorry, will probably go in a couple of weeks time. But basically the battery to battery charger, so we'll be driving along, it will charge these batteries. These batteries hold the 12 volt power to power all of our stuff. The solar power on the roof will come down through an MPPT. that just sorts out, that turns it in, I don't know what it does, but you need one. So it'll come down through there, and that will also charge these batteries, and then the ones that we're getting will all work together, so that I think whatever's providing the higher voltage will work, and the other two just back off. So basically, once it's all in, we don't need to do anything apart from wire all of our stuff back to these 12-volt batteries. So hopefully that makes a bit of sense. I don't really know. Like I say, it was all a bit confusing for me when I first started, because I was like, oh, do I have to turn the split charge on when I'm driving, and then remember to turn it off to put the solar on, and all this stuff, and basically just spending the money getting the right chargers, and they'll just do their own thing. So yeah, that's how it's going to work. So for these, we've got AGM batteries, and these are manufactured by, I think these are Extreme or something. There's about 150 quid each, so they're decent-ish. 110 amp hour each, so in total we've got 330 amp hours there. But what's really irritating is you have to half that. So if you buy 110 amp hour battery, you're really only going to get 55 usable amp hours, because you can't let these go down below 50% charge. Also 50% charge isn't 6 volts like I thought, it's like 12 point something or other. So yeah, these need to stay above 50%. So we've got 3 of those at 110, so that's 330 amp hours. So our usable amp hours is 165 amp hours. But yeah, we went AGM. I can't remember why, but when I researched it, I decided AGM was probably the better option. There are lithium batteries now which you can discharge right down to, I think, 20% or something, but they are very expensive, and the YouTube videos where people have put them in, I've seen people have had problems with them, so I don't think we're quite there yet, and especially for me who hasn't got a clue what I'm doing. So we've gone for AGM, which are maintenance free, completely sealed. I was expecting I might have to put like a little valve and ventilate them to the outside, but I can't find any hole on this that's to go into, but I will look into it and see. So yeah, that's what we've got. Then to charge them, so all I've got for now, all I've bought for now is our mains charger, and we've gone for the Victron Blue Smart IP22 charger at, I think it's 30 amps. I think this is the one that they recommended for this amount of amp hours. It's not the cheapest, but it comes highly recommended, and it's got Bluetooth, so I can monitor from my phone exactly what's happening with these batteries. Also, like I said, it's going to sort itself out with the other chargers, so we'll also be putting in a Victron MPPT, which again I can monitor from my phone to see what the panels are bringing in, what the batteries are doing. And then for the battery to battery charger, I think we'll probably for that just go with the Sterling Probat, I think it's called, Sterling Probat, maybe the 40 amp one or 60 amp one, I can't remember which one we need. But so I'm going to go ahead and open this up, because what I'll do now is in a minute I'm going to connect these batteries up and connect the charger up, and I will show you how I'm connecting the batteries, because again, quite a bit of research on this, there's the different opinions on how to do it, but the important thing is you need to, if you're running a 12 volt appliances, you will need to link these in parallel, not series, because series will then give you 24 volts of power, which is what we don't want. So it's a lot of waffle, and if you want to skip most of it or whatever, but like I say, I found it all quite confusing, so I'm just trying to give you what I learned, and it might be wrong. I'm going to be honest, I'm not an electrician or in any way electrically minded, so we will see how it goes. So it looks pretty simple, but I will read the manual in a minute, but basically there's a positive in there and then there's a negative, so I'm guessing I'm going to run a positive to the battery and a negative to the battery and then plug it in. I've got this box, this is all the kind of stuff you will need to order, and I'd give yourself a week to start ordering it, because what I done is I ordered some and then thought, oh crap, how am I going to fit that to that? And then I had to order another bit, and then things would turn up and there are different terminals on. So yeah, give yourself plenty of time to start collecting all the bits and pieces that you're going to need. Tea towel, I don't know what that's for. What I've done, if you're wondering what these are, is to secure these batteries in place, I'm going to run a batten along here, and then I've got some coach bolts, big long, I think they're 240mm, something like that, coach bolts. And then when I run the batten along here, I'll drill a hole for the coach bolts and poke them up from the top, then screw the batten down, so that'll hold them. And then I can drop a bit of aluminium, something on there, a bit of wood, whatever, and then just wing nut that wood down, so I'll have one of these both sides, and that will hold the battery down, and the battens will stop it from moving around. But I've had to put those ones in now because once I've got it all connected, I don't want to be moving the batteries out to do that. So that's what they are. Right, okay, so that will go there, I think. We'll see. Right, then I've got this blade fuse holder thing. So I think that's going to want to go somewhere there. So this is a blade fuse box. I've got a 12-way, so I can link up 12 different appliances to this. And it's got a common negative, so I can run all my negatives back to this. And then I can run this back to the battery. I think that's right. So I know that's extra cable, but if I can earth it all to the chassis, which I will have to do for the battery charger anyway, but if I use the chassis as my earth points for various things around the vehicle, and that's behind the cladding and the insulation, I have any earthing problems, I've then got to pull that out to get to it. So for me, I'd rather just get the run the extra cable back to this so that everything is here. Right, then I've got some 16mm squared cable, and this is for linking up my batteries. So this is 16mm squared, rated at 110 amps. So I don't think I'll be drawing anywhere near that at any one time. So then I've bought some beefy wire cutters and some of these ratchet crimpers. Now you can order these on the internet pre-made up to the lengths you need. But one, I wanted to do it myself because I've got no experience, so it's a learning curve. And two, when I was ordering the cable, I didn't know what lengths I'd need, so I could have guessed it, but then I might have ended up with slightly longer, and I want to keep my cable runs as short as possible. Right, then I've got various different ring terminals, some butt connectors for my 2.5mm cable, which is what I'm running my appliances with, just because I've cocked up and missed the switch, so I need to join some cable. Then I've bought this MIDI fuse holder with another ring terminal with an 80 amp fuse, and this is to be in the cable that runs from the battery to the fuse box. So I will site this here as close to the battery as I can, so that if there's a problem in that supply there, that will fuse out. So that's those. Got some heat shrink, never used that before, quite exciting. I've got some battery terminals to go on. Should check their fit, shouldn't I, really? So they're to go on there, but they don't look. Huh. Uh-oh. Right, so you learn something new every day. So basically I was trying to put this on there and it wouldn't fit, and I was like, oh, I think they sent me the wrong one. But it turns out, and this is why I really shouldn't be doing this install myself, but negative terminal clamps are very slightly different size to the positive ones. So I think I can go put these on. The reason I went for 3 110s instead of one huge battery or 2 bigger batteries is because of how heavy and unmanageable they are. So for me it's just easier to manage 3 smaller batteries than one huge battery. I now need to link, so for linking them in parallel, I need to link all the positives together to each other. So I'll go positive for this battery to positive of this battery, and then positive of this battery to positive of this battery, and the same with the negatives. Now the reason that I'm going to keep the cable length, so for all these bits of cable, so I'll end up with 1, 2, 3, 4, 5, like 6 bits of cable or something. I want them to be all exactly the same length. And the reason for that is because it's to help balance the charge. So there'll be a slight voltage drop from each battery. So if I had a short bit of cable on this one, then a huge long bit of cable, I think it just doesn't make sense. So I'm going to try and do that, and then my positive, I will run all my positives off of this battery. So all my positives for charging coming in and appliances going out will be connected to this positive of this battery, and then all my negatives, so my negatives for my charger, my negative for my appliances, will be off of the end battery. And the reason I'm doing, and that would be the same if it was 2 batteries or 4 batteries or whatever. The reason I'm doing that is because I originally thought I needed to just connect them up and then run everything off the negative and positive of the same battery, but all that means, the way I understand it simply, is that then this battery gets more charge than the second battery, and then more power is drawn out, or something or other along those lines. So I'm going to run them in parallel like this, so I keep my 12 volts, and then all the positives off of that one, all the negatives off of that one down there. So to make up these cables, I've bought these crimped ring terminals. They have to be 16 to match the cable size, and then this hole needs to be an 8 for an M8 bolt, which is what I've got on my battery. So depending on your cable size and what you're going on to will dictate what size ones of these you need. Then I'm going to measure the length of this cable so that I can replicate that on all the others. I'm going to install one of these kill switches. I don't know why, but I bought a panel mount one, so I'm going to have to, I'm going to drill a hole here, put that there, and there will be access. Basically the bed's going to come here, but there will be access from in the living end to just come in and that will just cut everything off. But before the kill switch there will be this fuse, so I'll probably mount the fuse there nice and close to the positive terminal of the battery, and then mount the kill switch here. I've bought these ratcheting crimpers just because I've got a lot to crimp. So you can do it, you can buy like this cheap metal thing, you hit it with a hammer. To be fair, these are only like, I don't know, 18 quid or something. So, and these will go up to a 16mm, which is the thickest cable that I'm using here. So they're really easy to use. It's got 16 on there, so you put your thing to be crimped inside of that, in the right place. Make sure your fitting's pushed all the way down, and then it's just on a ratchet, so just go all the way down, and that's it, crimped. Right, so basically this is your crimper, and on there, I don't know if you can see if that's in focus or not, but that's 16. This is your ring terminal. So that has got a 6mm diameter there, because that's what the switch takes, and then this end is for 16mm cable. So that's the cable stripped. I just twist it a little bit so it goes in there nice and neatly. You poke that in there like that, keeping it nice and flush to the insulation part of the cable. So in there nice and tight, and then you end up, that's not my best one because I was standing up, but you end up with this little dent in there, and that's that crimped in, and it should be that you can't pull it off. Right, I've waited all day for the heat shrink to turn up. It hasn't. So what I've done for now is I've just used some electrical tape. I've only got glue, which is irritating, but yeah, I'll change that to heat shrink eventually. But I'm starting to lose the light, so what I'm going to do is I'm going to connect all this up, and then I'm not going to film that because the video quality is going to be awful because of this light. I'm going to connect it all up, and then tomorrow, or maybe, well, if it works, I'll have a light, won't I? So you get it all connected up and then see. But if not, tomorrow I'll show you exactly how it's all wired up. Right, so it is very dark now and wet and cold and horrible outside, but I have got the basics connected. So I've got the batteries connected to the fuse box, and then I've just got we're making our own lights, so inside I've got a 12-volt bulb on this weird setup that I've started, so I've connected that in. So I'll just quickly show you, and then we'll turn it on and see what happens. Right, so it is dark and this is a mess, and it is all going to be tidied up, but just for the purposes of this, we'll give it a go. Now I don't think 12-volt can kill me, so it's not as bad as when I did the 240-volt, but over here somewhere in amongst all this mess there is a light bulb, so I should just be able to, it's got a switch on it and I've switched that to on, so I should just be able to switch this and, touch wood. Whew. Yes! Look at that! Woo! We have power! That is exciting. So yeah, I think what I'll do now is I'll have a go at getting the battery charger. Woohoo! I'll have a go at getting the battery charger hooked up as well, just so I can see what's happening. And then tomorrow I will tidy all this up and I will come back. It's like Blair Witch. Woo! Tomorrow, sorry, I'm really excited. Tomorrow I'll come back and show you guys exactly how it's wired up properly. Right, we're back. We've got some better light now. So I've tidied up, because doing the electrics turns out you make quite a lot of mess. But I'm just going to show you guys quickly the basically how I've wired these batteries up. So if we call this, I don't know, battery 1. So from this first battery, I've got all of my positives. So I've got my positive linking up to the next battery on there, and then I've got my output to my fuse box, which will be feeding all my appliances on there. And then also I will have all my charging inputs coming into that same positive. and then from that positive to the second battery, I've gone positive to positive, and then from the second battery to the third battery, positive to positive, and then the same for the negative. So negative from battery 1 to negative of battery 2, negative of battery 2 to negative of battery 3, and then on battery 3, so the third one in the run, that's where I've got all my negative terminals. So the negative going back to complete the circuit up to the fuse box, and then that's where the negative from the charging systems will also go. So yeah, the important thing, like I say, I've kept all my cable lengths from each battery exactly the same length. My cable length here, so you can't really see it because, like I say, I don't know why, but I bought a panel mounted cut-off switch. So my negative comes up here, my positive comes up here through this 80 amp fuse. This 80 amp, and it's important apparently that you keep this cable from your fuse to your positive as short as possible. That 80 amp fuse then goes to this on and off switch, which works. So if we turn, so it goes to there. From that switch, the cable then carries on and comes up and goes into the positive feed on the fuse box. So then that entire cable length is the same as this run for the negative, which comes back to the battery. So hopefully that should balance the batteries out. So I've given these batteries a full charge. I've hooked up for now just this cheap like USB port, just to give me a rough idea that the batteries are fully charged. That's reading 13 volts, so I think that might be a little bit too high, but I'm hoping that's just because it's a crappy thing and the readings aren't that accurate. Eventually we'll get a proper battery monitor, but I'll stick a volt monitor in these at some point and check them when I can borrow one. Yeah, but for now the charger's disconnected because I'm going to wait till I've got everything in place and then I'll final fit and cut the wires, just so that it ends up tidy. But yeah, I'm pretty happy with how it's gone. It's the hardest thing is knowing which connections you need to buy and which tools you need to do it and stuff like that, because like I say, you're like, well, how do I connect this to that and what size do I need? And so give yourself plenty of time and just do plenty of research. But yeah, that's basically it. So we have some sort of power. So yeah, thanks again for watching. Oh, I'll quickly show you something that's very exciting. This is our sliding door, and that is the very last of the insulation. So foil tape is gone, Celotex gone, recycled plastic insulation gone, that's all done. So the panel's cut, it's just in the house drying. So this afternoon I'll put that last panel on, and then that is it. It's all the insulation's done, so it's pretty exciting. But yeah, like I say, thanks again for watching. I will do some sort of video for the next stage of the electrics, so hit the subscribe button if you want to follow along, and we'll see you next time.